Welcome everyone to this Hour of Code Hangout. We're going to go straight ahead with our questions. So I just want to quickly welcome Simon Peyton Jones to the call, and we also have RSA Arrowvale School in Redditch. Can you give a quick hi?
Oh, we've got live now.
Oh, and we have great John Johnson. So everyone's there. Thanks everyone for joining. If you could just remember to mute your microphone when you're not speaking, and we'll go straight ahead with Simon. If you could, Simon is a researcher at Microsoft and the chairman of Computing at Schools, and he's going to give us a little bit more background on himself. Simon, if you'd like to do a little introduction, please.
Right, sure. So I went to university and studied mathematics, and I worked for a couple of years in industry. Then I joined University College London as a lecturer, and then I went to Glasgow as a professor. And then 15 years ago, I joined Microsoft Research in Cambridge here. And then I discovered that my children were having a hard time with ICT at school, so I got very involved with ICT education in British schools and helped make the change towards computing. That is, so that now that computer science is part of our school curriculum.
Thanks very much. Well, let's go straight into the questions. So, RSA Arrowvale, will you please ask your first question?
My name's Luke. What was the first thing you ever coded?
What was the first thing I ever coded? It was so when I was at school, which was in this was kind of like the early 1970s. Our school had one computer, and it was exceptional. Many schools had no computers. It was called an IBM Schools computer, and it was kind of like this big, really quite a big thing. And it had 100 memory locations, each of which could contain either an instruction or a piece of data. So you're used to computers with thousands of millions of memory locations. So this had 100 memory locations. And my first program, I think, was to play the game of NIM. If you've never heard of the game of NIM, you should look it up. It's a very nice little game. You can make a computer program, a very small one, that plays it and always wins, and that really appealed to me. Oh, I should say this computer was programmed only with numbers, so that each memory location contained an instruction. The instruction was a 6-digit number, and it had no memory. So every time you wanted to run the program, you had to type in 100 6-digit numbers correctly in order to run your program.
I'm glad we've come a long way since then. I don't know how many people would be doing computer science if we hadn't. Why don't we go to Durham Johnson, please? Could we have your question?
One of the biggest developments of the internet in the last decade has been social media. What do you think will be the biggest development in the next 10 years?
Oh, I don't know. I would never have predicted social media. I mean, like, I would never have predicted text messages either. Why? Because we had email for many years, and if somebody had said to me, "Oh, it's going to be very exciting to be able to send 140-character messages to each other," I would have thought, that's stupid. I can already send much bigger messages to my friends. Why would anybody care? And yet it's a sort of billion-dollar business. I think it's completely fruitless to try to predict the future. I'm not going to do it.
Let's have another question from RSA Arrowvale, please.
My name's Carl, and why do you think coding is so important to the curriculum?
Why is coding so important? So for me, the thing that's really important is not the technology, but the ideas. So I think of coding as like the lab work of the subject. If you're learning science, you learn sort of principles like how fast things fall under gravity or how tadpoles reproduce. But then you go into a lab and you do kind of experiments that bring it alive. You actually roll ball bearings down planes and with your stopwatch and so forth. So the lab work brings it alive. And for me, coding brings alive the principles of computer science. So it's not just a kind of useful skill, but it's a way of enlivening and bringing to life the subject discipline. So that's why I think it's important as part of a curriculum. Why is it motivating? Why does it bring it alive? Well, coding is one of the most creative things you can do. When you write a program, you're creating something that nobody has ever created before, and you're creating it out of pure thought stuff. right? Which if you build a building out of wood, then you can only build it so high before the wood is not strong enough and it falls down. If you build it out of steel, you can build it higher, but at some point it's going to fall down. With computer programs, there's kind of no limit. The only limit is our own ability to control the complexity of the programs that we write. And that's amazing. So it's like there are no limits. You can do whatever you like, and you can make a computer that can do something entirely new every day. And that's amazing.
Thanks very much, Simon. Can we have Darren Johnson again, please?
My question is, what do you love about your job?
What do I love about my job? So my job works for I work for Microsoft's research lab. So my job is a research job. My job description is to push forward the boundaries of knowledge and to try to develop ideas which will then will also enliven and help Microsoft's business. But so there's two parts to my job. So mostly I get out of my bed in the morning and I think, what shall I do today? And then I go and do it. That's an amazing job description. Hang on, I'm just going to shut my door. The wonderful thing about computer science research is that more or less wherever you study, you find something interesting. So my particular research interest is in an area of programming called functional programming. So the programs that you've written have almost all been the kind that you say do this and then do this and then do this. Your programs consist of more or less a sequence of instructions which the computers carry out one by one. But if you write formulae for a spreadsheet, you are in effect writing a program. That is, you're writing code, right? The formulae in those cells. If you wrote a spreadsheet with 100 cells, each of which had a formula, well, there's quite a lot of code there, but it doesn't look like a program in the same way. A spreadsheet doesn't execute step by step. Instead, you say the value of this cell is the sum of those other two cells divided by 2, say. So it's more declarative. You more say what the value of a cell is rather than how to compute it. And it wouldn't make sense to put in a formula equals, A plus print B, because when would the print take place? So it's a very different computational model, and the area of research that I work in is called functional programming, which means writing programs in which instead of saying do this and then do this and then do this, all of computation is carried out in a more spreadsheet-like way by evaluating a single formula that gives the result. It's rather amazing that it's possible to do anything interesting like that, right? You might think spreadsheets are good for calculating with numbers, but could you write a word processor or a text messaging system like that? An answer, yes, you can. In fact, you can do anything at all using functional programming. So functional programming is a completely different way of thinking of the whole enterprise of writing programs. You have to rewire your brain to think in a new way. And it turns out that it's a very interesting and fascinating way, and it gives a whole new understanding about the activity of programming. And some of that understanding is now percolating into mainstream languages. The language I'm particularly interested in is called Haskell, H-A-S-K-E-L-L. Go to haskell.org and look it up. It's the greatest thing since sliced bread. You'll enjoy it. And it embodies this idea of purely functional programming. So that's what I enjoy, the chance to explore something very beautiful and elegant, but quite radical. That's what researchers are allowed to do. They're allowed to explore things that are somewhat radical approaches. Now, increasingly, functional programming is being seen in mainstream programming, and that's very exciting to me.
Thank you, Simon. Another question from RSA Arrowdale, please.
Hello, my name's Elliot Phillips, and I was wondering, back in the olden days, everything was new enough done by binary code. But since with technology advancements, pretty much everything being automated, would it still
Actually, can I stop you a sec, because I can't really hear you very clearly. You could go closer to a microphone somewhere. Thanks.
Is that good enough?
Yeah, try again now.
Apologise. Back in the olden days, everything was done by binary codes, the old ones and zeros. I'm also wondering, with new automated engines and that, where everything's you just simply click and drag and it's automatically put in for you, would it still be effective to learn that?
Oh, you mean, is it still effective to learn binary, given that everything's so high level these days? Yeah. Is that your question?
Yes.
Yes, good question. Good question. So let me ask you an analogy. Is it useful to learn about, I don't know, something like combustion. When you drive a car, you don't really need to know anything about combustion. You just press the accelerator. You drag and drop your steering wheel, right, and the steering wheels move. But still, we think it's useful to know something about the underlying physical mechanisms that make the car work, not so much because it's directly useful to you for when you drive, but because it teaches you something about the way the world works, so that if you wanted to become involved in designing a car, if your car didn't work, then you might have some clue what to do about it. So it's something to do with learning the basics of how the world works. So let me give you a concrete example in terms of binary. So I agree that you don't need to know anything about binary to drag a window across your screen. But supposing I was to ask you this: if I was to read a book to you, or if I was to try to transmit a book to you over the internet, right, squirt it down a wire, how long would it take? Well, if it was a book like, let's take the Bible, then I might send it to you letter by letter. But then I might discover that there were frequent uses of a word like God or righteousness. And I might think, rather than sending you righteousness, R-I-G-H-T, repeatedly, I'll just say to you, look, whenever I say RX, I mean righteousness, right? Does that make sense? So I'd sort of compress it. So, and then when you decompressed it at the other end, whenever you heard RX, you'd write out righteousness. But I'd have taken less bits on the less information sent down the wire, right? So then you might ask, how much could I compress a book, right, like that? How you know, if it was a million copies of the word righteousness, then I could compress it a lot. I could say righteousness 1,000,000 times, and I'd be done, right? So that book doesn't contain very much information. But if it was, you know, all new words all the time, then it contains a lot of information. I couldn't compress it very much. So what is this thing called information, that some books have a lot of information and some have a little? Is it a quantity that you could measure, right? And if so, in what units would you measure it? Right, because we can measure, I don't know, heat or power in terms of watts, right? It's a numerical thing you can measure. Can you measure information? Well, actually you can. And what's the unit of measure? It's bits. Right, that very binary stuff we were talking about is the kind of unit of information, and you can speak about how much you can compress data by compressing bits. So it's, if you like, it's a kind of fundamental part of thinking about information and the world we operate in. So I'd like to encourage you to think of it not just as a sort of operational thing. What do you need to know to operate a computer? But an ideas, the exploring the world of ideas thing about what might information might mean. Does that make some kind of sense to you?
Thank you, Simon. Let's have another question from Durham Johnson, please.
Currently, I'm the only girl in my year studying computer science. So what do you think schools and the government can do to encourage more girls to do things like computer science?
Oh, congratulations. I'm so glad to see you, because women are horribly underrepresented in computer science. So well done you. And you would know better than me why your colleagues, the other girls in your year, don't want to do computer science. And I think you should be telling us, actually. I'll tell you one thing that is that I have as a hope, which is that now that the new curriculum encourages us to teach computer science as a foundational subject about ideas and not about technology, and to do so from primary school, I'm hopeful that if girls like you get hooked on the ideas of computing and indeed playing with computers at primary school, and discover that you can do it just as well as any boy, and you're jolly well not going to let any boy push you off that computer, then I'm hoping that by the time you get to secondary school, you'll maybe sort of get anchored in and not be so readily discouraged. But honestly, you know better than I do, and I'd like you to tell me. Maybe you can you tell me? Do you have any ideas of your own? Can I ask you a question back? What do you think?
I think there's a lot of stigma about girls and computing and what girls should and shouldn't do, and I think it's a societal thing that we need to remove. I think there are ways that the government and schools can. Yeah, I think the curriculum thing is a thing that will encourage more girls, because before we didn't do any of it, and it was kind of just considered a boys' thing, whereas if you've been doing it since you're very small, then it's it removes that stigma around it.
Yeah, I'm hopeful it'll be a normal thing rather than a weird thing for a girl to do. Yeah, but maybe there's actually a kind of, maybe it's like one of those phase transitions that while it's weird, it's difficult for it not to be weird. But once it becomes normal, then of course it's normal, and so it's kind of like a when you drop a crystal into a super cooled solution that crystallizes all of a sudden. Maybe you'll switch from one phase to another quite quickly. I hope so. Anyway, congratulations to you. Stick at it.
Thanks very much. Unfortunately, everyone, we run out of time. That's our 15-minute slot. But I wanted to thank everyone to be on the chat. Thank you, Simon, so much for all your really interesting responses. And thank you very much to Durham Johnson School and RSA Arrow Vale. And I hope you've enjoyed your hour of code this week, and keep at it.
Yeah, great. Thank you very much, guys. I'm waving. Wave back. Okay.